Hello everyone, this is DSA Zindabad. Today we are going to solve the 10th question of our DSA sheet, and the question is subarray sum divisible by k. Now let's look at the problem statement. Given an integer array nums and an integer k, return the number of non-empty subarrays that have a sum divisible by k. A subarray is a contiguous part of an array, right? Now our goal is to return the non-sum non-empty subarrays that have a sum divisible by k, right? And first of all, what do we mean by a subarray? Like, let's say we have this array 1, 2, 3, 4, 5, right? And now from this 1, 2, 3 can be considered as a subarray because a subarray is a contiguous part of an array. Like, it's not be something like, let's say we have 1, 4, 5. So this is not a subarray, right? This can be considered as a subsequence, but this is not a subarray. Subarray should be contiguous, right? Now let's discuss the first example. We have 4, 5, 0, -2, -3, and 1, and the k value is equal to 5. So from this array, what we need to do, we need to find out the total number of count of subarrays that have a sum divisible by 5. Sum should be divisible by 5 here. So we'll try to generate all the subarrays from the given array, right? So from this, we can see like we can form one array 4, 5, 0, -2, -3, and 1, the entire array, right? 4 plus 3 will be equal to 9 plus 0, 9, 9 minus 2 will be equal to 7, 7 minus 3 will be equal to 4, 4 plus 1 will be equal to 5. So its sum is 5 and it is divisible by 5, right? Now we can also have this single array since it is also divisible by 5, right? Now we can take this array out, 5, 0, its sum is also divisible by 5, right? Now we can also take this entire array, right? Which is 5, 0, -2, -3, right? So its sum will, these both will cancel out. Its sum will be equal to 0. As we know, 0 is divisible by 5, right? It will ultimately give us a remainder 0, right? That's why we consider this array also, right? Now we can also take only single 0. This is also divisible by 5. Now we can also take this array 0, -2, -3, right? 0, -2, -3, because ultimately its sum will be equal to 0, which is divisible by 5, right? So when we count all these subarrays, its sum will be equal to like 7, right? We can generate 7 subarrays. Like, first one is this, second one is this, third one is this, fourth one is this, fifth one is this, and we can also generate this subarray, right? Which is -2, -3. So 1, 2, 3, 4, 5, and we can also generate this array, this single array 5, 0, right? So all this count will be equal to 7 when we count all the subarrays, which give us the result, right? Whose sum will be divisible by 5, right? There might be some test cases where the sum, like, as you can see, like from this example, in all the sub arrays, sum is exactly equal to 5, right? Which is our target value. But there might be some test cases where you can find like, let's say our sum of a particular sub array will be equal to 10. Now, as you can see, 10 is divisible by 5. So we need to count this array also, right? Now, let's jump into the approach and let's try to figure out like how we can solve this problem, right? Right, first of all, let's talk about the approach. Let's say we have this array, this 4, 5, 0, -2, -3, 1. 4, 5, 0, -2, -3, 1. We have -2, -3, and 1, right? So for this, what we can do, like, we can just, like, first of all, let's talk about the brute force approach, right? Brute force approach, like, what does the brute force approach is like? Whenever we given an like array question, what comes in our mind, like, just traverse the whole array. Like, we don't need to know like we just need to know how many times we gonna repeat are traversing over the array, right? We just need to figure out this thing, right? Let's say we are on this particular element. So since subarray is a contiguous part, so we'll try to generate all the possible combination of subarray. In first one is this, second one is this, third one is this, and so on, right? So we'll generate all the possible number of subarrays, and same goes for 5. We'll consider this, we'll consider this, we'll consider this. Same goes for 0. We'll consider this, we'll consider this, we'll consider this, right? So we need to traverse over the array 2 times. Like there will be 2 loops, right? And third loop is for just calculating the sum, right? Because we just need to figure out like whether our some percentage, like k is divisible by k, right? It should be 0. This is our main condition. So we'll also have a third loop which calculate the sum of the entire array in a like of the subarray, right? Let's say we have our subarray in this. Let's say it have 1, 2, and 0, right? So the third loop will try to calculate the sum of this particular array, this which will be equal to 1 plus 2 equal to plus 0 equal to 3, right? And it will try to divide it by k and try to figure out whether its remainder is 0 or not, right? So its pseudocode will be something like this. So yeah, its pseudocode will be something like this. First loop is for like these 2 loops for iterating over the array, and the third loop is helps us to get the sum. This one is this for traversing to generate all the possible combinations, right? And this condition is for like whether our sum percentage k will be equal to 0, like whether it's this is for divisibility condition, right? And at the end of the like code will return the like number of possible subarray which whose sum is divisible by k, right? So let's talk about the time complexity and space complexity for the same. So since we are traversing over the array 3 times, like there are 3 loops. First one is this, second one is this, third one is this. So its time complexity will be near about big of n cube, and the space complexity will be equal to big of 1 since we are not using any extra space. So that's the reason where there is no space complexity for this code, like when we talk about the brute force approach, right? As you can see, like this is not the optimal solution, like because we traverse over the array multiple times, which will give us the time complexity around like big of n cube. So we'll try to reduce the time complexity, right? So let's talk about the optimal solution. Right? So we have given an array, right? And we need to figure out, like count the number of subarrays whose sum is divisible by k. And we try to do this thing in a like big O of n time complexity, right? Now we can think like for big O of n, we need to traverse over the array only once, right? Only once we can traverse over the array, right? Because like when we traverse over the arrays or like single time, like so what comes in our mind, like we just need to store some result over in some other data structure, right? This comes in our mind, like because we need to get the sum of those sub arrays. So we'll be sum storing sum, right? And storing also the frequency. uh, so what comes in our mind? Hash map, right? I hope like why we are using hash map like is clear to all of you guys, right? Now let's talk about like how we are going to use hash map in our problem, right? Since hash map store value in the form of key value pair, right? So we figure out like we're gonna use hash map, right? But how we gonna use hash map and what are those conditions, right? When we store the result of like some or some other thing in our hash map, right? We try to figure this thing, guys. This is not the direct intuition which just comes into your mind and you'll be like just solve the problem, right? So this is not the direct intuition. So now let's talk about this approach, like how we are going to solve this problem with the help of hash map, right? Let's say we have given this array, which is this array. So let's take this example, which is 2, 3, 5, 4, 5, 3, 4, right? And k will be equal to 7 in this case, right? So first of all, whenever we are doing this operation, this suggests of something like a remainder, right? So we'll try to get the remainder of each and every element, right? How we are going to get, let me show you this thing. Let's say from this array till this, its sum is equal to S1. So 2 plus 3 equal to 5. Now, when S1 is divided with K, it leaves something remainder X. Now, 5 percentage 7 is equal to 5, right? Now, let's say this subarray sum is equal to S2 and S2 equal to 5 plus 5, 10, 10 plus 5, 15, 15 plus 4, 19. Now, S2 percentage K also leaves the same remainder, right? It also leaves the same remainder. What does it mean? 19 percentage 7 will also be equal to 5. So as you can see, like both of these subarrays give us the same remainder, which is 5 over there, right? Now, as you can see, between these subarrays, right? This this subarray, just try to get the sum of this array. Like it will be equal to 5 plus 4, 9, 9 plus 5, 14. Its sum is equal to 14. Now, as you can see, like when we try to subtract S2 from S1, what is the answer? 19 minus 5 equal to 14. And this is divisible with K, right? So this is one of our answer, right? Like this is the first subarray whose sum is divisible by K. I hope like this like some visual is clear to all of you guys, like why we are taking a remainder into our problem, like right. Now in the similar way we'll try to get the same thing from each and every element, right? I hope like why we are doing this, like getting the same remainder from two subarrays, and the subarray which is present there in between those two subarrays is our answer. This is something kind of like prefix sum. I'll also attach the article link for the same in the description below. Now let's do a dry run on this problem, like how we are going to proceed, so that this thing is clear to all of you guys, like how we are doing this thing, like how we are taking remainder into our hash map and all of this thing, right? Now let's take the same example, which is 2, 3, 5, 4, 5, 3, 4, right? Initially, we'll be having sum, and this is a remainder, right? And we'll also store the hash map. What we'll be storing? We'll store sum and the frequency. What do I mean by frequency? Once we like dry run over this nums array, this thing will be clear to all of you guys, like why we are storing the frequency, right? So initially our sum will be equal to 0 and our remainder will also be equal to 0. What will be storing? We'll store the frequency of remainder. Because in the above diagram, as we can see, like whenever we get the same remainder, like over there, whenever we get the same remainder, then there is the possibility of getting our answer. Like there may be the possibility of like getting a subarray whose sum is divisible by k, right? That's the main reason like why we are storing the frequency of remainder in the hash map, right? So initially our sum will be equal to 0 and remainder will also be equal to 0. So just mark the frequency of 0 as 1 initially. This will be stored in the hash map as the as value, right? Now just add this thing, add the first element. 0 plus 2 will be equal to 2. Now 2 percentage, since our case value is equal to 7, so 5 percentage 7 equal to 2. Now its frequency is also 1 since this element is not present in our hash map, right? Now 2 plus 3 will be equal to 5. Now 5 percentage 7 will be equal to 5. Its frequency is also 1. Once again, I'm saying this like this frequency, the frequency of remainder, this thing we're gonna store this thing in our hash map in the form of value, right? Now again, 5 plus 5 will be equal to 10. Now 10 percentage 7 is equal to 3, right? So we'll directly store 3 and its frequency is also 1, right? So we are just building our hash map over there. Yeah, right. Now 10 plus 4 is equal to 14. So 14 percentage 7 is equal to 0. So as you can see from the hash map, 0 is already there and its frequency is 1. So we're gonna increase its frequency by 1. So its frequency will be something like 2. And while we are doing so, we'll increment our count by 1. This count will store the number of subarrays. Let me explain this thing like now, since we get the same remainder, so there might be the possibility of getting our subarray whose sum is divisible by k. Let me show you this thing. Like initially, there is this array, right? When we are getting the sum as 0. So let's say its sum will be equal to S1, right? So after this, there is this array, which is from this remainder, from till this position, there is this array. Let's say its sum will be equal to S2. Now, 2 plus 3 will be equal to 5, 5 plus 5, 10, 10 plus 4, 14, right? As you can see, like whenever we try to subtract S1 from S2, we'll be getting 14, and 14 is divisible by K, right? So the array which is present in between these subarrays is our main answer. So this array is our first array whose sum is equal to, let me just clear this array, right? So this will be our first array whose sum is divisible by k, right? Just in between these sub array, right? This is our first sub array whose sum is divisible by k. I hope like this approach is clear to all of you guys, like how we are proceeding further. Now let's proceed further with the diagram, right? Now after this, what will be storing? Since we get our first array, so we'll increment our counter by 1, right? So its value will be equal to 1. Now 14 plus 5 will be equal to 19. 19 percentage 7 will be equal to 5. Now, as you can see, 5 is already there in our hash map, right? So its frequency will also be increased by 1, which is 2 over there. Now, the array which is present in between these two will be our answer. Now, in between this, we have this array. Now, just try to calculate its sum, which will be equal to 5 plus 4, 9. 9 plus 5 equal to 14. And its sum is divisible by 7, right? So we'll increment our count value to by 1, and its value will be equal to 2, right? Now, after this, 19 plus 3 equal to 21. Now, 22. 19 plus 3 will be equal to 22. So we'll store its, since 1 is the first element, so its frequency will be 1, right? Now coming to this, 4, we have 4, 22 plus 4 will be equal to 26. Now it will leave the remainder 5. Since 5 is already there in our hash map, whose frequency is 2, now its frequency will be incremented by 1, since 5 occurs 2 times in our hash map, right? So its frequency will be equal to 3 over there. Now, since as you can see directly from the our hash map, which is storing the frequency of the remainder, now there occurred 5. Now between these 5, there will be one array whose sum is divisible by 7. This will be equal to 3 plus 4 is 7. Ultimately, its sum will be divisible by 7, right? Now we also increase the counter by 1, which will be equal to 3. Remember, guys, since uh, 5 occur 2 times. Like we need to get this frequency into this. Like instead of 1, we'll increment its frequency by 2. Why by 2? This will be directly shown in the dragon over there. Like I'll just increment its value by 2. This will be equal to 4. Now this is our first array, this is our second array, and this is our third array. Now just look in between these arrays, right? Just let me just mark with this. Just these array. Just try to calculate its sum. This will be equal to 5 plus 4, 9, 9 plus 5, 14, 14 plus 3, 17, 17 plus 4, 21. So now, as you can see, like this sub-array is also included, whose sum is divisible by k. So ultimately, we have a total number of 4 sub-arrays whose sum is divisible by k. I hope this approach is clear to all of you guys, like why we are doing this thing with the help of remainder, why we use sum as the like second variable, and storing the frequency of remainder, how many times a remainder is occurring in our array, right? Now let's discuss an edge case. Like let's try to figure out how we're gonna do the same thing with the negative numbers, right? Now let's take a different example. Let's say we have this array. Uh, we have this array. This is our edge case for negative numbers. For negative numbers, right? Let's say we have this array 2, -6, 3, 1, 2, 8, 2, 1, right? So initially we'll be having sum and remainder as 0, and 0 and its frequency will be 1. Now just try to add this thing. 2 plus 0 will be equal to 2, and uh, its k will be equal to 7, right? Its frequency is also 1. Now -6 plus 2 will be equal to -4. Now whenever you try to divide this thing, -4 percentage 7, what its result will be? Its result will be -4, but remainder can't be negative, right? So we need to fix this thing. How are we gonna fix this thing? uh, I hope this like I hope all of you learn this thing. Like let's say we have 7 and -4. Can we write this thing in the same way like this thing? 7n -4 plus 7 minus 7, because ultimately we are just adding and subtracting the 7. So this will be equal to this, right? So 7n -4 will be equal to 7n -1 plus 2. So we can write this thing like as 7n dash plus 2. So in the case of negative numbers, what we're going to do, we just add and subtract our k, right? K here is 7. So we'll be just adding 7 in the value, right? Now its result will be equal to 7 -4 will be equal to 3. So instead of storing -4, we'll directly store 3 in the remainder. So its frequency is 1. Now -4 plus 3 equal to -1. Now again -1 plus 7 equal to 6. Now -1 plus 1 equal to 0. Now 0 is occurring second time. So this array will be our first array whose sum will be divisible by k, right? As you can directly see, 2 plus 3, 5, 5 plus 1, 6, 6 minus 6 equal to 0. So 0 is divisible by 7. So we'll just increment our count by 1. Right. Now we'll directly move to this. 0 plus 2 equal to 2. 2 is occurring second time. So the array between this will also be taken into account. -6 plus 3. Again, it will be sum equal to 0. So we'll again increment our count by 1. So our count becomes 2, right? Now again, 2 plus 8 will be equal to 10. 10 percentage 7 will be equal to 3. So since 3 occurs already, so its frequency will be incremented by 1. So this array is also taken into account. We'll increment our count again by 1. 10 plus 2 will be equal to 12. 12 percentage 7 will be equal to 5. Now 12 plus 1, 13. 13 percentage 7 will be equal to 6. Since 6 occurs in our hash map, so its frequency will be 2. So the array between this will be taken into our answer. So ultimately, our answer becomes 4. So what are the arrays whose sum is divisible by 3? Let me write this thing for you. Like 2 minus 6, 3, 1. This is the first array, minus 6, 3, 1, 2, right? And the remaining sub-arrays will be 3, 1, 2, 8, right? This one is this array, 3, 1, 2, 8. This array, 3, 1, 2, 8. This is from this, right? Now the fourth array will be equal to 1, 2, 8, 2, 1. These are the possible number of subarrays whose sum will be divisible by k, right? So our answer will be equal to 4. I hope this approach is clear to all of you guys. Like, as I already mentioned, this is not the direct approach. So we'll try to figure out, like, we need to figure out why we are doing this, why we are storing remainder, why we are storing its frequency in the hash map, right? I hope all of these things are sorted out, like after the diagram. If not, like, just try to rewatch this video. Uh, I'm sure, like, just do the dry run with the help of like pen and paper, and all of this thing will be sorted out, right? Now let's just try to code this thing up. Now after this, like after coding, we'll try to discuss the time and space complexity for the same, right? Now let's try to code this thing. So this is our question, right? Initially, we'll be storing. This is for count. Count the number of subarrays. So we'll be storing all of this thing in a map in the form of key value pair, right? Now, initially, we'll be having 1. This 0 is our sum, and this 1 is its frequency, right? As I mentioned, we are going to store the frequency of remainder. This one is the frequency of the remainder, which is 0 initially, right? Now, after this, we'll have two variable. One is sum and the another one is remainder, right? Now we'll just iterate over the complete array num size. Now we'll increment our pointer. Now sum, we'll try to calculate the sum, right? And remainder is calculated by some percentage k, right? Now, if remainder is less than 0, this is for the negative edge case, right? Then what we going to do, we'll just add k in this remainder, right? Now, this condition is done. After this, we'll try to look whether the remainder is present in our hash map or not, right? Map.find remainder doesn't equal to map dot end. Then we'll just increment our answer then reminder's frequency, right? Now map of remainder will be plus plus. This is for storing the frequency in the final result, incrementing the frequency of the remainder in the map, right? Now after this, if this condition is not satisfied, then we'll directly tell that its frequency is 1 because it is not found in the hash map, right? Then after this, we are done. At the end of this, we'll just return our answer. So let's try to run this code. There is some error return. There is a typo over there. Return. This. Now let's try to submit this thing up. This code runs perfectly fine. Now let's discuss the time and space complexity for the same. So here we are. So this will require big of one time since we will just declare two variable over there. So it will also require big of one time. Since we are just iterating over our nums array, it will require big of n time. So ultimately, the time complexity would boil time to big of n, and the space complexity will also be equal to big of n. Why big of n? Because we are using hash map, right, to store the sum as well as the frequency of the remainder, right? I hope this approach is clear to all of you guys. Just try to do a dry run by yourself, and this question is extremely like then this question will be extremely easy to you guys. Like once you dry run by your own, right? Thank you so much for viewing the video till the end. Please like, share, and subscribe, and comment if you have any doubt. Thank you so much.